take in this moment. Remember this time right now, right before you see everything. I mean, this is going to change everything.
This is the dawn of a new era. This is the result of a collective dream.
Today is a historic day. 6.5 months ago, a rocket launched from Earth, carrying the world's newest, most powerful deep space telescope on a journey 1 million miles into the cosmos. It's a new window into the history of our universe. And today we're going to get a glimpse of the first light to shine through that window.
I am thrilled and I'm relieved because you know when you start something this big, you know there's always a possibility it might not work. It did work. We are so proud.
Right, here we go. Okay, so the first image is a deep field, and it's also a deep field with a cluster.
And the important thing to realize is that there's quite a lot of mass in the galaxy cluster, and it acts as a magnifying source, a lens, to stretch and distort the light and make intrinsically faint objects brighter so that we can see further away galaxies.
There it is. It's called Stephan's Quintet, and it's wondrous.
This is a very important image, an area to study, because it really shows the type of interaction that drives the evolution of galaxies.
So it's appropriate now that I send the broadcast to our colleagues and friends at the Space Telescope Science Institute in Baltimore. That's the scientific nerd center of the entire Webb mission.
We're sitting here outside of the Mission Operations Center, which is the key central hub for Webb. We are ready to see Webb's first image of a star dying, a planetary nebula called the Southern Ring. Wow.
NIRISS has found definitive evidence for water in a hot gas giant exoplanet's atmosphere. That exoplanet is called WASP 96b. And we can see from this beautiful data that there's water in the atmosphere. And also there's evidence for haze and clouds, which couldn't be seen before.
You know, every dot of light we see here is an individual star, not unlike our sun. And many of these likely also have planets. And it just reminds me that, you know, our sun and our planets and ultimately us were formed out of the same kind of stuff that we see here. We humans really are connected to the universe. We're made of the same stuff in this beautiful landscape.
I think we should all feel extremely fortunate to be here at this moment in time when all of this is happening, in the building where we control this technological marvel from 1 million miles away. The infrared photons that have been traveling across the universe for billions of years are captured by Webb's giant segmented mirror. They nestle their way into some detector, one of the amazing detectors that it has, and then they're sent across that 1 million mile chasm back to us, and then disseminated to the rest of the world.
This is where a new scientific journey begins, as thousands of astronomers throughout the world will now be able to access the JWST data for the first time to start doing science.
Webb's first images are just the first look. We have a fully operational telescope that will make new discoveries, and the science will fuel the sense of wonder and exploration for generations to come.
In the words of the famous Carl Sagan, somewhere something incredible is waiting to be known. I think those words are becoming reality.